Hey everybody, welcome to Systems Expert. Let's dive into the question.
Hi Clement. Today I want you to design Google Drive.
Google Drive. Okay, are we designing just the storage aspect of Google Drive, or are we also designing some of the products like Google Docs, Google Sheets, slides, drawings, all that stuff?
We're just designing the core product of Google Drive, which is the storage aspect. In other words, users can upload and create files which are stored somewhere in the cloud, and they can access those files and folders, move them around, replace them, etc.
Okay, but even just on Google Drive, just on the storage product, there are a lot of other auxiliary features, things like a personal Google Drive versus a shared company Google Drive, or shared files and folders. Like two people can share a personal drive or files in a personal drive. There's also stuff like what files were recently accessed, activity on files. Are we designing all of these things or?
So let's keep things narrow and imagine that you're just designing your personal drive. So forget about like shared company drives. And in your personal Google Drive, you can have folders and files, and that's kind of all I want you to take care of. And for short, I'm going to be referring to these files and folders as entities. But any other features like activity on entities or the recently accessed entities or starred entities, you can just forget that for now. And you can definitely ignore the sharing aspect. So being able to share access to folders and files. Let's just not take care of this in today's design.
Okay, so then I guess I'll write down that we are really just handling folders and files. Folders and files. Is it fair to say, you mentioned this earlier, but is it fair to say that we are basically implementing all of the basic CRUD operations on folders and files, like creating folders and files, or I suppose uploading files, moving them around, renaming them, deleting them? Is that what we're doing?
Yeah, and downloading files. But yeah,
Okay. Okay, yes, downloading. So I'll write in parentheses here CRUD operations, and I'll remember that we have downloading. Are we also designing a desktop client for Google Drive, or are we just dealing with the web application?
no desktop client. I just want you to design the functionality of the web application of Google Drive that you could see if you go on the Google Drive website.
Okay, so I'll put just web. And on the web, I know that you said that we're not dealing with access control lists, like sharing, files or giving people permissions to files, but do we still want to handle what would happen if, for instance, like I'm a single user and I've got two tabs open of my own personal drive on some same folder and I create a new file in that folder on one tab? Do I want the other tab to immediately see that? What if there are conflicts? Is this something that we should think about in our design?
So we're as I said before, we're not designing the sharing aspect. But if it's being edited by multiple clients, we'd want the changes to be reflected, let's say within 10 seconds to all clients. So if one client creates
Okay.
a file within 10 seconds, the other clients should see it. But for the purpose of this question, let's not worry about clients editing the same entity at the same time. Don't worry about like the conflicts that might cause or anything like that.
Okay. Okay. So I'll put just maybe like 10-second update. 10-second update if we have multiple clients, like two tabs in a browser accessing the same folder, but no conflicts. So this will simplify a little bit of the design. I guess as far as scale, like how many users are we serving? This is a global product, I'm assuming, but how many users are we going to be serving and how much storage do we expect these users to actually be using up in our application or in our system?
So let's assume the system should be working for a billion people and handle 15 gigabytes per person on average per user. That's kind of what Google Drive gives you as a free tier. So we can just assume the average is right at that limit of 15 gigabytes.
Okay, so I'll put 1 billion users. And like I said, these are global users, right?
Yep, exactly.
1 billion users and 15 gigabytes per user. Okay, so that's going to be a lot of storage. And is this a highly available system that we're looking for?
So first and foremost, I want to talk about data loss, which is not tolerated at all. We need to make sure that once a write or addition or an upload goes through and the client receives a confirmation, it will not disappear or get lost until the user removes it or deletes it. And then in terms of availability, which is what you mentioned, we do need this to be highly available. A lot of people rely on this. So
Gotcha. Okay, so I'll write then no data loss
yeah,
and highly available. That makes sense because when you upload something to Drive, you basically assume that it is safe for good. And I'll put HA for highly available.
okay.
So these are two slightly separate things. I think that the data loss is going to mean that we're going to want a lot of redundancy or a lot of duplication rather of our data.
Yeah.
So let's see. I think that I have most of what I need to start thinking about a design. I might have other questions that come a bit later on, but for now, I think I should be good. What I'm thinking here is that maybe it makes sense to write out all of the operations, like all of the CRUD operations that we mentioned before, to get a clear picture of what exactly we're supporting, what exactly we're designing, and then to jump into the storage, like the backbone of our system and everything else. Does that make sense as a sort of tentative plan?
Yeah, let's do that.
Okay, so then I'll write down here all of the operations. So the first operation is going to be, what would be the simplest operation? Maybe uploading a file, or actually creating a folder is probably even simpler because a folder really is just an arbitrary structure. It doesn't have any actual data that you're uploading. It's not like uploading an image. So I'll put create folder as the main one, or as the first one, create folder. Then I will put upload file, and maybe download file should come with it. So upload, download file. What next? After, I guess, we get into really all of our CRUD operations. So things like deleting both a file and a folder, moving both a file and a folder, renaming both a file and a folder, and getting both of them. So I'll just write this here. I'll probably write move, delete, rename. Rename is effectively kind of like edit, and then get, and then these are both file and folder.
Okay.
And I guess you can't really download or upload a folder, right? You just upload or download a file.
Yeah.
Okay. So I think that that's every single operation that we want to support. Is that correct?
Yeah, let's stick to those.
Okay, perfect. So now I can start to see things a bit more clearly. We're going to have to figure out where we store both folders and files. And I suppose we have to ask ourselves, like, what does a folder or a file really look like? Like, what is the data behind a folder, behind a file? And I feel like there are two different types of data. There's information about a file or information about a folder. And this is going to be stuff like when the file or folder was created, what the name of the file or folder is, who owns the file or folder. That's kind of like almost like metadata. And then there's the actual contents of a folder or file. And I suppose a folder, like I hinted at before, a folder doesn't actually have contents. If anything, the files or other folders that are contained within a folder, they are part of the metadata that I'm talking about. But files definitely have actual content. And that's a very different data. That's more of kind of like an opaque blob of data versus the more structured metadata that I just mentioned. So I think that our system is going to have to be divided into two sort of separate pieces of storage or storage components. One of them is going to be purely for file contents. And I'm really thinking that we're going to be using a blob store there, like GCS or Amazon S3, because, and I suppose if we're doing Google Drive, we would not be using Amazon S3. We would be using GCS, Google Cloud Storage. But that lends itself perfectly to just opaque pieces of data.
Okay.
But then for entity information, this metadata piece that I'm describing, that feels like we could probably use something like a key value store, because that's almost like, configuration parameters about a particular entity, about a particular folder or file. So I think a KV store makes more sense. What do you think?
Yeah, that makes sense. Are you thinking about how scalable that key value store will be? Are you just going to have one? What kind of strategy for storage are you going to be using? And what kinds of key value stores are you going to be using? Because different ones give you different guarantees.
Yeah, so maybe we can start then with the key value store section of the system.
Okay.
And so this would be for the information that we're storing about entities. So maybe I'll start with create folder actually, and I'll get into what exactly the KV stores look like in a second.
Okay.
So I'll answer your question in a second. But if you create a folder, all you're really doing is storing information about that folder or the representation of that folder in storage. So this lends itself perfectly to what we want to do right now, which is to describe how these KV stores work. When you create a folder, you're going to be storing stuff in the KV store. And I suppose to your question, we would want to have highly available KV stores because we need that high availability that we talked about before. We are going to want to probably shard our KV stores because we're dealing with so many users, 1 billion users. But I'm trying to think, like, would we want to shard on a regional level? Regional sharding is often pretty useful, but here I'm thinking that I know that once again we're not dealing with sharing, we're not dealing with permissions, but you could still have multiple, like we still eventually have to support having one person, let's say in the United States, accessing a file or a folder, and another person in India accessing the exact same file or folder. And if we do eventually have to support that, I don't think that we can shard on regions, or if we do, it's going to be a lot more complicated because of replicating data across regions and all that. So I'm actually thinking that we may want to shard our key value stores either on the file name or the entity name, like if we're talking about a folder on the folder name, or maybe
So wait, the name or the ID?
Not the name. Like the name is the human readable name that can be edited even in the rename option or rename operation. No, we would be using the ID, some kind of unique ID that every entity is given. But I'm wondering if that might actually be a little bit more cumbersome, because then it begs the question, where is that ID generated? It shouldn't be generated client side. But I actually think that it might be just easier to shard our KV stores based on the owner ID. So for instance, the person who owns the drive in which a folder or file is created, they would likely have a unique ID as a Google user, right?
Yeah.
And we would use that ID as the sharding key for our KV store sharding strategy. Does that make sense?
Yeah. No, that makes sense. That's great.
Okay, cool. So I'm gonna go with this then, and I'll maybe give myself some space here and write our KV stores here on the right. So we would have multiple KV stores. I'll draw a couple of circles. These would be our KV stores. And you said what types of KV stores? We said we want them to be highly available. I think we could probably go with something like etcd or Zookeeper. Those would give us some good guarantees there. And the idea is, again, we would have like multiple or a lot of these KV stores, and we would be storing stuff in them based on the owner ID of the entity that we're storing.
Okay.
So that is the storage solution. And I suppose if we go down to the client level, like the client issuing the create folder request, so let's write create folder right here. If you're issuing a create folder request, we definitely need some kind of load balancing because we're not going to be hitting these KV stores with a billion users. So we'll have some kind of load balancing here. All right, LB, and this would be based on the owner ID, what I'm going to call the owner ID. Okay. And the reason I'm not calling this user ID is because if a user is creating it in somebody else's drive, if we have granted that permission, even though I guess we're not handling that, but if we have, we want the owner of the drive or the owner of the parent of the folder to be the sharding key. So owner ID, and we would hash on this. So owner ID hash. And I'm trying to think, we would probably here have some proxies that live in front of the KV stores.
Okay.
And these proxies could handle, maybe some caching. If we do have ACLs eventually, permissioning, they could do the checking of if a user has permission to create a folder here or whatever. So does that make sense to have a couple of proxies or a bunch of proxies here?
Yeah, let's do that. I think that's reasonable to have.
Okay, cool. So I guess I'll just write, a bunch of circles here, and these are going to be our proxies. So the load balancer is going to, like, these create folder requests are going to the load balancer. The load balancer then goes to all of the proxies based on the owner ID hash, and then the proxies go to all of the corresponding KV stores. And They do some extra logic, whatever we want to be there. Now, as far as what the actual entity information looks like in the KV stores, maybe I should write that down. I'll write it down to the side here. So we would probably have a lot of properties to store per entity, all sorts of metadata about the entity, but the ones that I'm thinking of right now would be probably, name of the entity, and maybe I'll put a bracket here. We would store the owner ID, so I'll put owner ID. We would probably store, I'm thinking that a folder is going to have to store pointers to its children, meaning all of the things that it stores inside of it. So it would probably have, a list of folders and files, and these would be folder and file IDs.
Okay.
So here I'll write, children. I'll just make it an empty list for now. This would be the default thing. Here we would also have, I guess, a unique ID. And that's about it for now. Oh, I suppose if we are going to have, we could use maybe the same object or the same schema for both folders and files and just have some sort of Boolean that says, is folder. I'll go with this.
Okay.
We could also have just different types of entities, but I'll just go with a Boolean for now. So, is folder, and this would be just true. Okay, so that's kind of what I'm thinking about for this for now. And that's it, I think, for creating a folder, right? That's all that you're doing. Creating a folder comes down to creating this object and storing it in one of the key value stores.
Yeah.
So I think we can move on to storing actual data, which means file data. And to store file data, we would probably have to upload a file. So it would be the upload operation that would trigger this. So I'll write upload operation here.
Okay.
Upload file. And I suppose after uploading, we'll get into downloading. Downloading is probably going to be a little bit easier. But so if we are uploading a file, let's say we're uploading an image or a big document, Maybe a good way to start this would be to estimate how much storage we're actually going to need to store, all of our users' data.
Okay.
So we had said we're going to have a billion users, 15 gigabytes per user. So let's quickly estimate that. A billion is 1,000 to the power of 3. So that's 15 times 1,000. That's 15 terabytes. Multiply that by 1,000 again, 15 petabytes, and multiply that by 1,000 again. We are at 15,000 petabytes of storage. That's a lot of storage. Yeah. And we also have the no data loss demand. And no data loss means that we need to have probably duplication or even more of our data. I think that we would probably want to have our data stored in multiple different availability zones, such that if one or even two availability zones are hit by natural disasters or huge outages, there's always one that still has a user's data.
Okay.
So let's say that we need at minimum 3 sources of truth for a piece of data. That means that we need 45,000 petabytes, so 50,000 petabytes. I'll write this down just so that we have a sense of the scale here. 50,000 petabytes. Petabytes. Okay. I'm trying to see if there's a way to optimize this, because I think at a Google scale, we can afford to have 50,000 petabytes. It's just a lot of machines, but there's certainly one optimization that comes to mind, which is, I don't know if it'll necessarily impact this value. This certainly still is our upper bound for how much storage we need, but one way that we could optimize this, store less data basically, is not somehow design our system in a way that duplicate data doesn't get stored twice. And I'm not talking about the no data loss duplication. That is voluntary duplication. But imagine I upload the same picture twice to my Google Drive. Or imagine that 2 users upload the same picture or the same document or whatever, right?
Mm-hmm.
Even if they're completely separate users who live, across the world from each other, if they upload the same exact file, you don't want to store that twice. Or if you do store it twice, it's not an optimal use of your resources. So I'm trying to think if there's a way that we can basically have, in the same way that here we said we would have these global key value stores, we could have global blob stores here that somehow avoid any duplicate data from being uploaded. So if 2 users are uploading the same data, then they just they don't actually, one of them doesn't actually upload that data. It just accesses the previously uploaded version of that data. Does that make sense as a kind of direction to go in, or?
Yeah. So by access, you just mean when it tries to upload a certain part of that data, it just gets confirmation that it's already there.
Yeah, and I guess the fact that you said a part of that data makes me realize that we could actually split up any file that gets uploaded into smaller blobs of data, because there might be duplication in smaller pieces of data. In other words, 2 users might upload 2 images that share some data. The images, maybe half of them is identical, but the other half is where the images differ. And so you would split the images up, and smaller blobs that constitute the full image, we would check if these smaller blobs are already stored in the blob storage, and if they are, then we just wouldn't upload them. We wouldn't re-upload them. We would just say, hey, that thing that we already have there, that's going to be, where this part of the file lives. Does that make sense?
Okay. Yeah, let's do that. That sounds great.
Okay, so then I think we're going to do that. So the idea would be, if a user uploads a file, we have to go to some API servers. So, we're going to have some API servers here. And I suppose, as usual, we would have to do some load balancing. So I'll actually move these a little bit up. So we would have some load balancing here. That splits up our requests, or rather distributes our upload file requests across these API servers. And these API servers, their duty would be to split up a file that's being uploaded into blobs, into smaller blobs of data,
Okay.
and we would have some kind of algorithm or logic that determines how many blobs or what the size of these blobs is, and so on and so forth. But they would split up the blobs, and then they would store them in our final blob store solution, and we would store them. I think we would have to synchronously store them in multiple blob stores, because like we said, we want that no data loss thing. Mm-hmm. And I think I said three, let's go with a minimum of 3 blob stores. So we would synchronously store all these pieces of data in our minimum 3 blob stores, and maybe we could have some asynchronous replication to have even more blob stores contain all of the information.
Yeah.
And we would do that check there of like, hey, is this blob already stored in the blob storage? And I guess before I finish this drawing out, how would we check though if a blob is already contained in the blob store? We could hash our contents. We could take a blob, hash the contents of the blob, and compare that to all of the blob. That would be a little bit complicated. Or so every blob has an address. Every blob has a pointer or an address that we can reference it by. So we actually name our blobs. We name the address or the pointer to a given blob by its hash, by the hash of its contents. So if you have a piece of data like right here, let's say this is your blob, you hash the contents, you get a value, let's say X, and if X is already in your blob store, then that means that, like, if X is a pointer or an address in your blob store, then that means that this content is already stored in your blob store, and you can just throw this out. You don't need to store it. Does that seem sensible?
Yeah, and that's actually called content addressable storage, and it's actually really good to be using it here. It makes a lot of sense.
Yeah, and I'm trying to think actually. So it's cool that it has an actual name, and I'm actually trying to think if like it comes with other nice things. Like, first of all, that means that every single blob would be effectively immutable. Because if we were to upload a slightly different blob, it would have a different hash, and so we would have the contents would be hashed differently, and so we would have a separate blob entirely stored, which is not bad, because if the blob is immutable, then if we do need some kind of caching somewhere in our system, caching is going to be a little bit simplified, right? We don't need to like overly optimize to have our cache be in sync with our source of truth. Our cache is always only going to be, it's always going to be pointing to immutable blobs, if that makes sense. So I kind of like this this approach. So I guess I'll complete my drawing out now. Okay. Let me erase this. And here, the load balancer, would it be doing owner ID hashing? I don't think we need to, because we are storing these blobs not based on owner ID. We can just have like round robin load balancing here. So I'll write RR for round robin. So here we're getting a bunch of requests going to this load balancer. This load balancer then goes to all of our API servers. And I guess I'll call these API servers like blob splitters, because their job is to split the blob that's being uploaded, or the piece of data. So blob splitters. And then we go to our blob stores. And I suppose if we do want some kind of caching, or if we want to do some other processing on our blobs, maybe we're going to be like compressing our files or something. If we want to do any kind of processing, we might have, just like we have proxies here, a set of proxies here. So I'll write just, potential proxies here. Proxies, and we would have probably another load balancer here. And this load balancer would, if we're going with caching, it would go with like blob, we would load balance based on blob hash. So I'll put this here, this goes here, this goes here. We could do some some blob hash load balancing here. And I guess maybe I'm complicating the system a little bit here by adding this additional functionality, but I do think that it could be helpful. In theory, we don't need this entire section, I think. We could just go from the blob splitters directly to the blob store solution. Does that make sense? Like, are you following me?
Yeah, but I think in reality, the fact that you have immutable blobs is very useful, as you said, for caching. And so I think being able to have like this separate layer of proxies that might do something a little bit different, like you said, compression or caching, would be very useful, especially since the blob stores are going to be kind of on the global plane. So latency to hit them might be a little far.
Yeah, and so the caching would end up being pretty useful.
Yeah.
Especially if you've got users who are using Drive, very frequently. Okay, so then I'll keep this for the proxies, and I might even add here, like in red, that we can do some caching here. And again, the caching would be done basically based on the blob hash. And so this would be load balancing here. And then we go to our final blob storage solution up here. And so here we would have 3 blob stores, because I went with three different, duplications or triplication, I suppose, at minimum. But I think we might even want more. So like I mentioned before, I think we could have a bunch of other blob stores living behind the scenes that we would asynchronously replicate to. But here we would synchronously write the blobs to each of these blob stores. So basically like a single proxy here that gets a single blob would go here, here, and here. This one would go here, here, and here. I won't
draw the third one. Yeah.
I'll skip the third one, but you get the idea. And so these are our blob stores. I'll write this, blob stores. The idea is that these 3 blob stores would have to be picked very intentionally. You would want them to be in different availability zones. Like if there's a hurricane, you don't want all 3 of these to get hit. These might live in the same data center, or at least like 2 of them might live in the same data center, but maybe on a different part of the network or something. That way they're isolated from each other, and then you probably want one in a completely different region. And then even if one goes down, you still have the other 2. So maybe like this isn't a hard requirement that the writes here succeed across all 3. Maybe you just need them to succeed across 2 of them, and you trust that that's enough. And then they immediately have async replication with the others. And here, I suppose this would probably be another service. So I'll actually erase this. You would probably have, some kind of, async manager here or controller. So I'll put async rep controller, so CONT, and this would kind of go to all the blob stores and asynchronously replicate to the others. Does that make sense?
Yeah, that's cool. Seems like that would work.
Okay, cool. And this satisfies our data loss or no data loss policy. It also satisfies our high availability policy. So I'm pretty happy with our blob storage here. And we still get decent latency. Even the fact that this is a global, these are global blob stores, I think we get decent latency because we can make use of the caching, like you said. Here, like overall, we might have caching here, and in general, this is Google Drive, so we are okay with waiting a few seconds to see a folder completely load. Like from my experience with Google Drive, latency is not the most critical thing. It is, like you said, the no data loss and the high availability. Yeah. So overall, I'm pretty happy with this. Maybe we can talk about the other operations now. So download file, let's see, would download file be difficult? I think download file would be, and I suppose, wait, I did forget one thing about uploading a file. When you upload a file, you first store it in blob storage, and then you need to do what we did for create folder, right, and store it in the KV
Mm-hmm.
store. And so here maybe because I guess in this object we would probably want to have like blobs, and this would be a list. For folders, it would probably be empty, but for files, it would be a list of blob addresses or pointers. That way, we can just from here we can just point to all of our blobs in here, the blob hashes.
Okay.
But we do have to store this, and we can only store this once we've stored the blobs. And I suppose the blobs is the really the critical thing that we have to store. So maybe uploading file, you to keep this simple so as to not add another service here. I think we might be able to naively just store in blob storage, get a response from our servers, we get back to the client, and once the client gets a response that the blobs have been stored and has all the hashes, we just like go here and make a request here to store the object with the blobs. Does that make sense?
Yeah, that's cool.
And I suppose like the good thing about this is that even if, let's say like the request fails or something, and you maybe like do a retry, with our solution of checking to see if blobs of data already live in our blob store, we can just re-upload the file and it just will not get uploaded. We'll just be effectively making a check to see if that file is already uploaded. And then for downloading the file, I think we're actually dealing with something very simple where we first go to the KV store, get the object, find all the blobs, go to the blob store, get all the blob hashes, put them together, like recreate the puzzle and get the file and then download it. Does that make sense?
Yeah, I think that would work.
Okay. So then I guess the final few CRUD operations we said would be move, delete, rename, get, and all of these would be for both files and folders. So let's take care of these now. I guess I'll just put them as like the rest of the CRUD operations because I think these are going to be all pretty similar. So the rest of CRUD. And let's see. Let's go through them one by one really quickly.
Okay.
So if we're renaming a file or a folder, this seems like it's very easy. All that we do is we go to the KV store, go through the load balancing and the proxies and all that, and we just edit a field in this. So I think that this should be fine. Then if we're removing, or rather moving a file or folder, that actually gets a little bit tricky because if we're moving a file, let's say from one folder to another folder, we have to update the parent folders, both of them. We have to remove the file or the folder from its original parent folder, and we have to add it to its new parent folder. So I think we might want to structure our entity infos here, these objects. We might want to make them kind of like trees, like tree data structures, except that they have a pointer to their parent, so they're kind of doubly linked, if that makes sense. So here we would, I'll erase this. I'll grab this little bracket and move it down, and we would have just like parent, and this points to the ID of the parent or the parent ID. Does that make sense?
Yeah, let's have that. I think that could be useful when trying, for example, if you're in a folder and you're trying to go up a folder. You actually need this, otherwise you'd have to scan the whole store. So that makes sense.
Yep, exactly. Cool. So then that's what we'll do, and I guess moving a file or folder would be just that. You update the parent of the thing, the entity that you're moving, and then you update the children of the old parent and the new parent.
Okay.
So that's pretty simple. Deleting would be the same thing. Deleting, you would just find the thing, delete the object or remove it from the KV store, and then update the parent's children. I suppose, do we want to handle things like the concept of a trash folder where an item doesn't actually get deleted immediately, it just gets placed in the trash, or are we good without that?
So I think we don't really need to talk about this too much, because at the end of the day, you can think of the trash as like a special folder, maybe with a special indexing, so that some maybe other process can go through and clean things up afterwards, but we don't have to go into it.
Okay, yeah. And I think that's sort of how I would have thought to do it if we did have a trash folder, but this simplifies things. And I guess then the last thing that we would need would be to remove the blobs. Oh, I guess handling blobs might be a little tricky because we don't need to remove the blobs from any object here. We just delete the object of the entity that we're deleting. Like if this is a file, but do we want to delete the blobs from the blob storage? We actually can't do that because of the fact that our design relies so heavily on blob like deduplication or blob reuse. We might have other entities that are pointing to the blobs that are being used here and that are effectively being kind of deleted. So let me think. We don't want to delete blobs. At the same time, I don't know if it's a good idea to just leave, like if a blob actually has been deleted in the sense that it's no longer being used at all, right? Let's say that I've got an image that is completely unique and I'm deleting it. We would want to get rid of those blobs in blob storage. So I'm wondering if we could have some kind of like some auxiliary service here.
Okay.
That lives in between the KV stores and our blob stores, and that either watches the KV stores for updates to blobs and sees, like, how would we do this? We would have to know if a particular blob, maybe let's simplify things and deal only with one blob, but if we have a single blob, we would have to know if it is being still used by an entity. And we would know that from the KV stores, because the KV stores have all the information that we need, right? Like, in other words, we could have a service that aggregates all of the references to a particular blob, or maybe we have multiple services that watch all of our KV stores for like blob hashes and keep track of if at any point in time a blob hash reaches, like a blob hash is referenced 0 times. And so I guess we probably would need another storage solution, like another database where we hold like the number of times a single blob has been referenced. Does that make sense, or am I going completely off mark here?
No. So you're designing a garbage collection system, which I think is roughly how that would work. You're just trying to do reference counting, so counting how many times a particular blob is referenced, and then once it drops down to 0, you could probably mark it for deletion, but the blob stores would have to implement some kind of internal operations that allow you to do this in a concurrency safe manner.
Right. And that's where things would get, I feel like, a little bit tricky. Do you want me to get into that or no?
No, I don't think you need to get into that. It could be a systems design question of its own.
Okay. But just to clarify so that I'm on the same page as you, the idea is you would have a garbage collector here. So I'll put garbage collector GC, and this thing would live sort of in between the key value stores and the blob stores, right?
Yeah, that's it. And it would also talk to a database to keep the reference count for each blob.
Yeah. We would have some other database here. Okay, so I won't go into that. I'll just put DB, but I won't go into that then. The idea is there would be some entirely different system here that handles all that.
Yep.
To not basically make our blob stores hold useless, unneeded data. But I think this is everything then. Maybe the last thing that we forgot is the updates, because we did say, I think, we said no conflict, but we want 10 seconds update if we have like multiple clients talking to the same folder or the same file or something, like a rename. So here, I think we can do this very easily with just some polling. Like maybe here we talked about deleting, renaming, and moving. We forgot getting. Getting is the same. It's literally you just go to the key value store and boom, you have the object with all the description. So we can pull our get like our get operation, get file or folder, we can pull every 10 seconds,
Okay.
or every 8 seconds or something from the client, and this would be a very simple, maybe naive way to implement that part of the system.
I think it could work potentially. You could imagine that like whenever an entity info changes in your key value stores, you set kind of the last modified time, and so your proxies in red there could easily kind of I guess figure out if something has changed recently or not.
These proxies. So you're saying like instead of pulling, we could have these like push to the clients, or
No, but if we are worried about the amount of data that get file or folder returns, we have a lot of different users. We could use that to just return the last modified time, and then if that has changed, then you can get the rest of the info.
oh yeah, I see. Oh yeah, that would be a clever optimization. Interesting. Okay, I think that covers the rest of the things that you wanted me to cover, or the features of the system. Is there anything that I'm missing here, or?
No, I think you've covered all of the operations we wanted, and you went through all the requirements. So I think this looks good.
Okay, great. Thanks.
Thank you.
With that, I hope that you found this video informative, and we'll see you in the next one.